This is, I know, not my standard intro. This is future Corey just giving you a warning about this video that you're about to see. It's about 3 hours long, and I'm leaving it even though I don't consider it a success. That is, I was able to successfully change my big switch statement to tail call optimized stuff, but I spent a lot of time trying to figure out why the things I was trying wasn't working. And it comes down to, but I use a lot of tools. Okay, so why am I still putting up this video? First of all, significant effort. It was about 3 hours of working and recording. But I use, first of all, you do see the what procedure I follow, what things I have to do to get tail call optimization to work, and also what tools I'm using, command line tools, in order to explore the results. In other words, I think it's educational, even if it's a bit long. And by a bit long, I mean very long. And sometimes it's like an hour of me staring at code and talking through the things that I figure out. And by the way, some of the problems were, like for example, in examining the backtrace, I'm seeing the same thing over and over. And it takes a while before I figure out that, oh, it's being passed by reference. And so when I'm being shown this backtrace and it says it was called at this point and called at this point and called at this point, it only shows me the last value. In other words, I'm not seeing it all the way along. And so all of that's to say, the code that I ended up writing, I do get tail call optimization, or I do get the tail call to work, but it's actually slower. And you would say, why is it slower? Well, I had to do a few other things. And so I'm actually wanting to record another video of just exploration of this topic. And again, my videos are everything is live. I don't pre-do the work because, well, that's not the point of this series. Other series I might. But this particular series, it's for you to see everything that goes into making of this project and this exploration of figuring out, can I make something more efficient in this way or in that way, and the learning what tools I need along the way. Okay, so having said that, if you want to watch the entire video, that's good. It'll be boring at parts. You may see something I don't. But if you only want the kind of crux of it, then watch the first part of it and then skip to the end, the last, I don't even know if it was 20 minutes or whatever, or maybe less than that. The code is not committed. Well, it is committed. It's just I don't have a tag for episode whatever. Maybe I should. I could add that. But I put it in a separate branch so that it's not part of the main branch. And I may do some more work on that separate branch just to clean it up so that's more obvious of what I'm doing there. But yeah, that is that's the state of this. And yeah, at this point, I'll turn it back over to past Corey, who has no idea of the pain he's about to encounter in this. So, thank you. Bye. Hello, and welcome back. My name is Corey, and you're my rubber ducks for the evening. And this is the series of episodes where we are creating a programming language from scratch using our C++ coding abilities and a few basic tools like, or fundamental tools, I should say, like Flex, Bison, Google Test, and ICU. Of course, Vim is our text editor, and we've been going at this now for, what episode did that say we were on? 87 maybe? Yeah, it's it's been going on for a while. And today is a big episode. And that is, we want to do some refactoring. We want to replace a big switch case statement with a bunch of tail call optimized lambdas. And you know what? Let me just give an example. So I went ahead and just by way of preparation. By the way, I normally say nothing up my sleeves, right? I haven't pre-written any code. And actually, even the thing I'm about to show you is not part of the code for this project. It's just to show you the example of what we're doing. Normally, I do this, make clean, and I don't want to compile yet. We'll get there. And then I'll usually show make log the last, make log, no, not make, get log. There, the last commit message was the end of episode 86, the previous episode. And if I say get status, no files have been changed. So 100% live coding, which means it's usually a little bit of work. So let's do this. Let's sorry, just had to stop. I was thinking, and also I heard something outside. Okay. What I'm going to show you is, well, we're going to want something to compare with, and so I think I'm going to edit the make file just for a moment and put our optimization instead of OG. Let's make that optimization level 3 just for the moment. And now when we make our test, well, we'll just let that run. Make test, there we go. And what I'm going to show you is a website called Compiler Explorer, godbolt.org. I believe that's the guy's last name, actually. And what do I have two open? I don't think I need two. I've got two programs here. The first one is, I should say the second tab is kind of like how our program is. All that you need to think about is there's an execute function, and inside of it, we just keep on going through a loop, and then we switch on that value. And on the right hand side, we have the assembly breakdown of what are the actual instructions that are happening. And can I make this larger for you? That's probably better. Let's see if we can go a bit larger. There we go. What did I go to? 22. We'll do that on this one over here as well. Okay. So the main thing I want you to see is on this switch, right? You see things like this. Compare this and jump if it's equal to that. Otherwise, compare the next value. Jump if, jump A, JA. I don't even remember what all these, it's a jump instruction. Another compare and jump, compare and jump. And yeah, it's hard for a compiler to optimize this type of code, especially the larger that it gets. And so as such, I want to break it into this type of a structure. And by the way, for each one of these, let me go back just for the moment and say what happens at the end of the break. Well, it says jump to .L5, and if we go to .L5 right here, it's just jump back to .L9, in which case we just run the comparison again. And so the further down into the code block that your work is, can I say it like that? The further down your opcode is, the more comparisons it has to make to find where it goes. So an optimization could be, we'll put your most commonly used opcodes at the beginning. But I would kind of like to be able to get rid of all these comparisons and jumps, and rather to say, you know what, can I just jump to it directly? And one way of doing this is, now we've used the word bytecode before. All that these are, I probably should have called this opcode, you know? Opcode execution. How about that? Just for it's still calling it. I mean, this is still called bytecode though. Oh well. And I need to make this larger so you can see it. Now, if we look at the disassembly for this one, source number 1, there we go. We'll make its source code larger. What you'll see is we've got, first of all, each opcode is its own lambda, and it's inside an array. Now, I've tried to be very careful to put all of the opcodes in the same order in the switch statement because I knew that this was coming. And the goal is for each one of these, what happens is you call the bytecode of whatever the first program instruction is, you index into that array and call that function. And then it in turn, rather than going through that big loop in a switch statement, it just says, you know what, look and see what the next instruction is, index into this bytecode or opcode execution, whatever, array, and execute that function. And so you've got a function that calls a function that calls a function that calls a function that calls a function. And the problem with calling functions is, of course, there's stack overhead. The work that that has to be done to prepare the stack so that it can go into the function and return. Unless optimization level, I think it's 2 and 3, will look for something called tail call optimization. And what it does is it says basically, if, number 1, all of the arguments are the same type, everything in the stack that was being called is the same type, and there's nothing to do after the function is being called. So if I'm returning a function that's being called and there's nothing that has to happen afterwards, no strings that have to be cleaned up, anything like that, if it is the very last thing, then it can make an optimization. And that is, it can just reuse the same stack frame without having to go through all of the stack setup and teardown. And that also means your stack doesn't grow infinitely long. Well, not infinitely, but if you're... Think about this. The way that I'm proposing to do this is you write a function and it executes opcode or instruction 3, then 4, then 5, then 6, then it jumps to 14. Each one of those is a new stack frame. But by using tail call optimization, it will reuse those stack frames. That's the goal. And so, if we look to see here, how does this get called? We see that it moves this line right here, number 21. It just indexes into it, and well, in this case, it is calling that function. Okay, fine, it's calling it. But if I add an op-03 and it recompiles, now bytecode, where is that? I'm looking for the word bytecode. Oh, this first one, it looks like it got optimized into this location. That's okay. I'll show you on the second one. Right here, have to go back up. Have to find it again. There we go. It moves bytecode, whatever, it's indexing into it, and then it just jumps to whatever this was pointing to. So you're no longer having to set up everything. And anyway, it's a tail call optimization when you get to 03. And it's faster. Should be. So we want to see if we can convert our big source, not opcode. Shouldn't be source anyway. It should be program. I mean, it is source. Program execute. Oh my. I'm just... There we go. This program execute and all of these opcodes into one big, well, into that bytecode array. Yeah. It's gonna be big. We'll have to see. And I don't know if it's gonna be faster. I won't know until the end. So one of the things we wanted to do, that's why I went ahead and turned it up to optimization level 3. We've compiled everything, and we have on the right, yeah, just right down there. We've got this fib.tang. It's a small Fibonacci function that asks for Fibonacci of 30, and it takes a little bit of a while. So if I build apps Tang, and I have to say -s, I think, right? Yeah, -s, and feed in fib.tang, it prints out the number. Okay, and if I do time of that, that's, here, let me do this one more time. And I'm just going to capture that. And there, I just pasted it into Notepad++. And that is our current performance. And now we want to see if we can start. This is going to take a while before we even have a compilable stopping point. So, having said that, we're just going to jump in. So, let's see. The problem is, let's see. In my solution that I showed a moment ago, I had this I wasn't taking into, so frame pointer, stack, PC stack, the execution stack, the frame pointer, the PC, all of these, and the context itself, they're all local stack variables. And now those need to become part of, yeah, this. I think the best thing we can do is using our, I'm going to call it Lambda, is a void star. So it's a pointer to a function. It's a Lambda that takes, what is bytecode? Just open this up really quickly and get down to our classes, program, well, get bytecode. Bytecode is a vector. You know what? We can just say bytecode. So this is going to be bytecode ampersand bytecode. I'll use that. What else? Our program counter, the frame pointer, a vector of garbage collected ampersand that will be called the stack, a vector of size t ampersand, which is the PC stack, a vector of size t, which is the frame pointer stack. Nope. Oh boy. And then the vector of a map of u integer underscore t, comma, garbage collected reference, and that is the library alias stack. Is that everything that we need? Now, in case you're wondering where I was getting all of this, I was just looking right down the list here. PC, FP, vector of garbage collected, vector of size t for the PC stack, vector of size t for the FP stack, and that should be an ampersand. PC and FP are just an integer, basically. So I'm not worried about that, but everything else I want passed by reference. Vector, map, blah, blah, blah. Yep. And then we just say while. Okay. So now we're going to say bytecode lambda, and we will call this bytecode lambdas, is an array that is equal to something. And now what? This, I think, can do that. And I think, okay, so just starting here, this should compile. Make test. Bytecode lambda does not. All right, and yeah, it's gonna say all the unused stuff. What did I mess up? There we go. PC has not been declared. Oh. So as usual, these can go away. Well, I could leave that there. PC. What I'm working on is just something that I can copy and paste a million times. So this is going to be size T. Size T. Oh, did I had a problem with vector up there, which probably means I have a problem with the vector here. Now I'm to unused parameter. Okay, now here's the question. Can I just say pound define bytecode lambda args as as that, and now say well, let's just copy that. And just see oh, now I'm getting that unused. I don't think I can put that there. Let's see if it complains about me having it there. So the next one that's complaining about is PC. Okay. So all right, now let's make this slightly more readable, shall we? Nope. There. Now, we want to start copying stuff. What is the best way to do this? So I think I'm going to say, nope, not like that. This is going to be ugly. I know it is. Before we do all of these, let's just try it with one. Well, that's all right. I'll do this. And now we need to call, what would go at the end? Open something and then close something. Okay, so what would go here? It would be bytecode open PC, right? PC, and then inside bytecode PC FP stack PC stack FP stack library alias stack. And of course there is no this for bytecode. Where is that? That's going to be in the stack check. Normally I use this all the time, but now we're actually going to be moving away. And it's going to say, I don't know what to do with the break. So for the moment, let's just turn this into a return. Can we do that? I can tell you really quickly. What does it execute? It returns a context, so we cannot do that. Okay. For the moment, what I'm going to do is I'm going to copy that, and just call one L for lambda. And instead of a break, we will make this be return, and then instead of break here, return, and We no longer need the thises. The these. All right, so now if I replace this with an L stack check, are we getting a compile? Everything's compiling. Okay, one other thing. We're going to do a pound define of something, let's just say next bytecode lambda. Rather than calling that, and then that will let us do okay. So having done all of that, of course the last thing would be like to say, you know, redo the indentation, but we now have something to work with. We know that we're going to have to call or have a comment, okay, and we know that we're going to have to have that next bytecode lambda, whatever it is. Let's do this one more time. We've got pop. Let's do peak. What will this look like? There's that. This needs to be an L and an L stack check. Oh, the this. All right. And of course, like I said, we can always do that. I think I'm just going to keep on going. And what is an easy way of doing this? Well, we're about to find out. So we've got peak, and I'm going to pick up at poke and go all the way down. So I basically copied it 600 some odd lines. I don't know if you just saw that. I'm going to put it right there. I know that this first one is going to need this. And now what I think I'm going to do is, can I do this and just say case and then look for the next case? Divide modulo negative not less than or equal to, greater than or equal to. Ooh, I did two of them. Equal, not equal, period. Index, slice, get iterator. Iterator next. Is iterator end. Cast. Call function. Return. Print. Was that the last one? One moment, getting a phone call. All right, and I'm back. Sorry about that. And the last thing I was doing was I was seeing, let's see. Right here is where that would be, and then we should never reach this. But I think we'll be using that in just a moment. Okay, now, so we've got all of these. We're going to have to go back up to the top and start changing this. And can I do... So all of the executes need to become L execute. All right, and I think I can do what I want to do here. I want to substitute execute for L execute globally. And now I've got L execute. That's for return. If I go up, L execute. Okay, I need to do the exact same thing with stack check. Should have just gotten the... You know what, I can do that. L stack. I don't want it to include this one, but just say from line 90 down to line... do I have too many? Oh, yeah, I do. Down to line 890. So let's do 90 to 890, substitute stack check for L stack check. And what's funny is later we're going to change it back. But, okay. Go back up to line 90. And now, so I think we can do the same thing. Was it 90 to 890? And we're going to substitute case space opcode colon for, can I do slash space, and that's it? Okay. Need to get rid of the break and that. All right. And now, just going to do this. Uh-oh, there were some cases that should not have been. I'll find them soon enough. Can I look for / star colon? Nope. Didn't really work. think that'll work faster. Let's get more of it on the screen. More on the screen. Oops. You know, if I just hit undo and then redo, that'll take me back up to where I was. Okay. Disaster averted. You're wondering what I'm hitting. I'm basically calling www to move forward by a word, capital D to move everything from wherever the cursor is to the end of the line. And I've done a search for the next. Now here's the problem. Call func. This break. So I've got a break in a couple different places. Break. I need that next bytecode lambda after each one of those. Or, so I'm not getting rid of the breaks yet. All right, now so I'm in the return. So line 745. Now I want to go up to the top and just say, does the next bytecode lambda return? There. It's a return statement now. Okay. I don't remember what. Oh, 745. Back to this. WW capital D. Next. Oh, I've got the same problem here. Do I really, though? No, I don't. Okay. And now I'm at the last one, because print is the last one. And then this is the default. So, what's the point of the next bytecode lambda? Well, I want to up at the top. So this next bytecode lambda, I want it to be if PC is greater than or equal to, not stack, bytecode lambdas. Can we do size of bytecode lambdas? Should be able to. If that is the case, then return. No. We want to do a stack pushback. Return. So it's always going to check to make sure that the PC is within the size of bytecode lambdas. And if it's not, then it will say unrecognized opcode. Otherwise, oh wait, so PC should not be bytecode lambdas. Nope, it is not size of that. It is... No, I was right. Because, well, PC, no bytecode. Size of bytecode is a vector, so we should say dot size. Okay, if it's greater than or equal to, then say no. This is a check for to make sure that so it's not a check for PC. That's the problem. Okay. We need to, first of all, if PC is greater than or equal to bytecode dot size, then return. Simple enough. Simple enough. Else, if bytecode sub PC is greater than or equal to the size of that, then it's an unrecognized opcode. So if the PC that we want is beyond the PCs that are available, we exit. We just stop. Else, if the bytecode that we're about to look for is outside of the range of the lambdas, then we don't recognize the opcode, return. Otherwise, we call bytecode lambdas. Yes. All right. So I think that is everything. Just going to hit save and see what it doesn't like. Okay. Whoops. Can't scroll up with that. Is it the same error over and over? Maybe. Size of to incomplete type. What? Bytecode lambdas is an array. I should be able to ask for the size of an array. There is an easy way to fix this. We're going to edit the include opcode. And just at the very end, say opcode count. And this is meant to be the last one, and it is represents the size, defined there. And I think, can't I say that this is no, it's where a U integer t, is that how I do that? How do I declare a type with an enum? I've done that. You know what? I've done it. Here, let's look it up. I don't think it's going to be there. Well, let's see. Type defs. No enumerations. Just look through these really quickly. Oh, look. Yeah. Preprocessed state is an int. So how did I do that? What's in the AST node? Well, AST node class, but still. Preprocess colon. There we go, colon. Now, in order to do this, we probably have to say pound include macros. And you know, since I pound included the macros, I really need to include that as a dependency in my make file. All right. First error. And this is meant to be opcode count. Is that what it is? Opcode underscore count. All right, and now else if was not declared. What? Well, how about that? I don't know how this language works. What are you talking about? Oh, and now I've got all the problems with the thises. Nope, I messed up on the previous one. Ooh. Lambda args. Oh, for the period. I've got to have Tang. Ooh, okay. What is Tang? Well, I mean, I know what it is, but what is the type? In the program, here we go. There we go. Program class, Tang. Well, is it a shared pointer to Tang base? Is that what it's asking for? So when I call It's left-hand side period. So a computed expression period takes a shared pointer. Oh, that is ugly. I think I would rather have program being passed in. Yes. Okay, so that means we've got to get program in there. Where did I put this? Sorry, having to scroll up and down. You know, instead of bytecode, we could pass in program. That might be better. So here's what we're going to do. We're going to undo the thises. All right, and we're going to ask for, instead of a bytecode, we're going to say program, and for the next, we're going to pass in program. And now, for all of these, it's going to become program.bytecode. So we need to, so from line 105, is it 890? Nope, further. Oh no. There. 809. Okay. 809. So from, what did I say? 100 to 809. 100 to 809. We're going to substitute this arrow bytecode for program dot bytecode. All right, so wrong window. I mean, I know this is a big refactor. Okay, so now in these, instead of program.bytecode, it's private. Of course it is. So I'm arguing with myself at this moment about how I want to solve this. What I think I'm going to do is just say from line 76 to 809, substitute program dot bytecode for program dot get bytecode. I mean, I wrote that. I think I did at least. And I'm going to do this so I can see where the problem is. That is, I can see how far to scroll up. Yeah, I didn't have to go up as far as I was going. 56, so I'll stack check. It should. Oh. And got another problem, and that's right here. Oh, the opcode count. A little stack check. There we go. $293. This is program.tang. It's private. We may have to have a get tang function. And program, no, I meant include. Include program to the Tang. What is this? I mean, it's the Tang program. To the Tang instance. This is going to be a source slash program dot cpp, and we need that get Tang. The context. Did I not pass in the context? How am I not giving it a context? I kind of need the context. So we've got the um, hmm. So the period is wanting think it'll like that. Just to get past this for right now. 803, yeah, we no longer need this. I don't think it likes the get tang being const. Unless I just wrote it wrong. That's possible. Oh, no, it needs to be program. And that can be const. And I just don't know how to write functions. Now, we're not actually using this code. Just realize that. Yet. But at least our tests are passing. All right. Can we switch to using this? What would it look like? Okay. So it wouldn't be returned. We would just call bytecode lambdas of PC program.get, or it would be this bytecode. Because we are in the program thing right now. And we would pass in this PC FP stack, PC stack, FP stack, library, alias stack, and then context. And context is that, yeah. that is everything that will go away. And then this will pick up. In theory, in a big theory, this will work. Segmentation fault. Of course there is. The question is where? We have no idea. So it's probably in the way that I'm calling. Are we starting? You know what? So happens we can run this. Okay, so gdb of ./build/apps/test. Run. Oh, we got really far into it. Backtrace. Okay. Test CPP. Is it because there's nothing there? Edit test, and what line is it? 1848. Why did I do that? Get back to your right size. There we go. 1848, and look, that is an empty one. So there is no bytecode to execute. All right, that would be why. So if PC is less than this dot bytecode dot, or this arrow bytecode dot size, which means there's something there, but let's go back, recompile. Okay, everything seems to be working. Now the question is, did we actually make anything faster? I don't know. I do want to, since we've done a few things, make clean, make test, just rerun this one more time. And we might not have gotten anything out of this. I still prefer this method, but we'll see. Of course, if all of our tests pass, that means that we at least did everything right. That is in terms of our just redoing my formatting. All right, so all of our tests are passing, and now comes the moment of truth. No, wait, what did we do before? Segmentation fault. So, does that mean it's not doing our tail call optimization? It's a very good question. First, I want to find out what's failing. So I need to know something. I need to know for GDB redirect standard in. With GDB --args. Oh. So if I type in a GDB --args /build apps Tang -s fib.tang. Just curious, will that work? No, it doesn't. Okay. This is big. Program execute 354. At least we can do that. frame pointer is equal to 39. So that means we're 39 deep. Could that be it? It's on an add thing. Okay. What I'm doing is I'm looking, okay, vector.h, and this is vector.h, 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 vector.h. So there's a lot of vector.h stuff here, which makes me think that we're not... I'm not moving down. I'm moving up, and it's... You can see the stack number going up. And up and up. That means... we are not getting our... Oh, see, continue without paging. Probably not going to be able to finish this. So, okay. While this is running, what I'm thinking is happening is that you see that we're at 20,000 deep, which I know that that's what would be happening, right? For each thing that we execute, we got to the end. We're 22,003. Okay. So it's something with a vector. Well, I mean, that's what I'm thinking. That's keeping it. At user include C++. You know what? I'm curious. User/include C++ 11 bits stl vector.h. And this is 1061. It scares me looking in here. Oh. It's calling this. Is that keeping it? I mean, using the angle bracket. Is that keeping it from? That's a good place to look. So all of these we can see it's in calling it that there's something with an angle bracket. Let's see, 834. See how we're calling this bytecode? If I say auto bytecode is equal to this bytecode sub PC, and then do how about target? That way there's no shadowing. And then I bet, since I wrote this using a macro, I'm really glad I did that. Everything's still passing. That's a good thing. Still getting a segmentation fault. And if I run this, what did I say? -s and feed in fib.tang. $355. This is the one. If I say BT for backtrace, This is interesting because this time it's not in. Notice it's not giving me anything about the standard template library. This is just our program execution. How deep did it get before? This is 22,341. I'm wondering if the problem is trying to pass too many things. What if I just like put it all in one struct? Would C++ then be convinced that it's going to be an ugly set of changes to do? But in short, that's what's happening. We're not getting the tail call optimization. And this may be a lost cause. I don't know. But again, that what we did just a moment ago fixed the I just want to see on this when it says 437, what's it talking about? What is 437? Next bytecode lambda. And the next one up, 159, 159. But this one is 355. That's at the beginning. The other one is 776. That's when it's calling it. So now curious about something else. Quit, yes. If I do obj dump, object dump, what do I want to know? I want to see the source. Can't you add lines like with a -L or something? I think so. Obj dump -s-l build objects and program execute.o. That's not what I needed. Let's look at that again. What do I want to see? Dash capital S and pipe it into less. All right, and what is the name? So I am getting call, not jumps. Okay, so this is line 801, for example. Which is in the print, of course. Call why are we calling garbage collected stuff? Oh, well, we do have to call something in next bytecode lambda. That's the pushback and all that other stuff. And a deallocate. This is 801. I have a really interesting question. Would it make sense for, by the way, so for this, for example, to be like that? Why? To make sure that everything make test. I want to know if this will force, like, for example, the string. I'm wondering if it's not going away because there's stuff on the stack that needs to be cleaned up, and it's not figuring that out yet. That it can be cleaned up before that. So I'm going to look for :802. Oh, 803 is what I should be looking for. So /:803. There we go. So that's right here. Move. We're calling what? Something with a vector of bytecode lambdas, Tang program, vector, garbage collected, blah, blah, blah. So I'm going to, so we're still at 803. I want to take this next bytecode lambda (803) and put that there. So instead of next bytecode lambda, we're calling it explicitly. Just so I can see what happens for this return. And 811 now is what I'm looking for. Line 811, colon 811. A lot of moves. And a jump. But not a call? So we're 793. That is up there. That's interesting. But still, it's jumping. It's not doing a call. Okay. Does it do the same thing if I remove those two? Hello to the person who popped into the chat. Look at it again, and we're looking again for 809. Move, 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 push, move, call. There's some other calls. So if I had to guess, I would say and look, there's an 810 where it's calling some garbage collected stuff. I'm gonna redo this. And again, we're looking at line 811 here. Go back to the beginning. There we go. Colon 811. And now with the curly braces, jump if not equal, move, 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 whatever, pop, 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 jump. Not a call in there. Well, and this belongs to something else. So I think that's what it is. I think we've got to wrap them in a parentheses. The problem is that means by the way, if I do this now, now it's line 803. It's going to look a little messier because there are some things that we're calling in there. But still, at the end of the day, we're getting our jump instead of a call. I think that's what we need. So, the question is that what I need to start? Is that what I need to do? Do I need to do that? That is not what I meant to do. Okay. I think using the function is going to take a lot more work. I already have it there. Now, up at the top, got to get all the closing ones. Okay, these got to skip. That one has it. Okay, now question is will this run any better? Let's just run it and see if it'll work. Forget the timing. Segmentation fault. So the GDB of it run with -s and feed in fib.tang. This is in a different place. In the less than, operator less than, and in the lambda, of 492. And then it's, just so I can see this, after 741, which is, and then 741, 741, 741. What? This is in the call function. Multiple levels of call function. Okay. I'm going to do one of the worst things possible. I have never written one. A go-to statement. I know how they work. Just tell me what the syntax is. No, I'm not going to do it. And it's just that. Okay. The reason is because if you notice it's in the same place, 741, 741, 741, that means we weren't able to 741, 741, 7 over and over. That means at that spot we weren't able to clean up the stack. So for all of these, it's going to be oh, my caps lock is on. There we go. And this is going to become go to And now to delete those. Yeah, shouldn't have deleted that one. All right. Try our test again. $841. Don't think it'll like that, but I'll do it. Still a segmentation fault, no. Now this time it's at a less than. Okay. First at 492. Got 492. Which is less than. Then 843, 843. So what is equivalent 843? So it still is not, all of these are 843. So it's not doing, I mean, if I could say C, continue without paging, and it's going to go and probably to get to 22,000 and blah, blah, blah. But all of these are the same. That infinite loop? So I don't know if I've got an infinite loop or if it is just running out of stack space. PC is 3. PC is 3. PC is 3. Program counter is 3, 3, 3, 3, 3. Is that just the last value? Maybe it is getting the tail call optimization where it's rewriting the same thing over and over? That's at 492, but it's the 843 that's... Okay. So 843. We've got call that move sub, compare, move, call, move, a bunch of moves, call, jump. Then 760. Well, oh no, here's a call. So I think it's still not cleaning up something, so it's doing a call. Can I force this? To perhaps not need the goto. That was just a reorganize. Sorry, I know I'm going up and down, but it's because I'm checking a few things each time. All right. If the type is this, else if the type is that, else, there's a reason I'm using else, or adding it as an else. Wait, did I just, no, that's else. Okay, so at this point, we no longer need that one. If that, else, do I need this go to anymore? I don't think so, because I can, this one is an if, and I can say else. Do that. And that will keep it from now this one, okay, so I don't think I have any go-tos now. Oh, I do right there. But I don't need this one. Ooh, I have one here. But I can say else. Is there a go-to? There is no go-to now. All right, so everything should clean up after itself. Segmentation fault. Ah. Well, I want to see this now. No, wait, the backtrack. It's in a different place. So this is 492, isn't it? Now we're doing the less than check, but everything after that is 836. 836. and I'm still in call func. And I bet that it's that all the way down. I look at object dump again. Go to line 836. See a couple things for it, but it's a really big one. But here's the killer. We still have call. Why? Because what is it needing to clean up? Remove the arguments from the stack. See, just for a moment, for the cast to string, line 699, /:699. Wait, what? There it is. Had to search in the right order. Okay. Move. I just want to know. not, but NOPL. Turn them off. Doesn't matter. It's going to go away. Okay. So one of the reasons I'm thinking this is behaving in this way, or how I'm interpreting it, let me put it that way, is that when I'm running my backtrace, I'm only seeing that one. Now maybe that's the problem. Maybe the problem is with the optimization. So, you know what? If I edit the makefile and change my optimization to 2. So getting a segmentation fault, but if I GDB it, run $836. $836. It's probably going to go all the way down to 22,000. These are all line 836. I mean, these are all, again, looking the same. But this is what's suspicious. The execute there, and then it's immediately 8:36. Let's remove the optimization. Segmentation fault. I know to do that. Now, okay. 106, 110, 308. Oh, those are in program execute. Oh no, that's what it is. Okay. 8:36. Wait a second. So for this one, 106. It's in a peak instruction. And program counter 6, frame pointer 31. The stack has 33 items in it. $110. And then 380. Which is in a function call or declaring. That's declaring a function. How far did we get into this? There's a lot more frame pointers. $50,000. If we look at 213, just because I want to know, that's the null. That will be the very first instruction, which then calls the next one. 212. Oh, that's the, yeah, lambda. Then 143, 142. That's a jump, because the very first thing is we jump past the function definition. And then it would go on. Well, 381. Which is, yeah, declaring the function, because it jumped down to where it declared the function. That's what we would expect. So, what's that 106 did we say? We're peeking, we're loading something. That's program counter equals 33, then program counter is equal to 3. I mean, in this I would expect to bottom out. The question is why isn't it reusing the stack frame? a shared pointer? That's a good question. Everything is a reference. What if I just make these? Well, I'd have to change the performance anyway, but we'll just run it. Segmentation fault. Okay, vim makefile. Replace that with a 3. Was that it? And it takes longer. Oh. Yeah, 1 second. Well, it functions but is not faster. Just switch back to master. At least we're passing. So it's almost like I feel like I know how I could make it faster. It's just not working. So we are back to, I didn't lose the work, right? If I say get branch, get push, origin, tail call inefficient, it's there. But yeah. Wish this had worked out better, especially since I just spent, what, over 3 hours on it. Guess I will have to find my efficiency gains elsewhere. So, all right, okay, that's it. I'm calling it, and I guess I will probably never post this one. Oh well. Bye.